Sure. So artificial intelligence uses chipsets, mainly GPUs, that are extremely high TDP, so high in total dissipated power. And as a result of this, legacy air cooling is a challenge in order to cool the thermal heat load that's actually emitted by these GPUs and servers. Liquid cooling, specifically single-phase direct chip, has become preeminent as part of the scale-up of NVIDIA's Blackwell platform. And we're seeing massive adoption of infrastructure to support single-phase direct-to-chip liquid cooling. This is a historic moment in the data center industry because it's really the first time that liquid cooling has been adopted at hyperscale. And so what we're seeing is a lot of changes in data center design to accommodate both the high power loads and also the infrastructure required to support liquid cooling. So some of the challenges really are around how to implement liquid cooling in an existing data center, which is already air cooled. So a lot of the infrastructure needs to be upgraded and changed, especially CDUs, coolant distribution units, that are used to reject the heat from the white space and also control temperature, flow, and pressure of the secondary loop in the white space. What we're also finding, though, is that some of the new builds that are occurring for the adoption of AI are just now starting to come online. And there's challenges in the market as well around time to power, grid interconnects, and also all the power infrastructure that's associated with implementing AI. So we're in a momentous period of change, and it's an exciting time. So our CDU 1 megawatt is capable of delivering up to 1.35 megawatts of total heat rejection. And we designed the product specifically for NVIDIA Blackwell. We are on the NVIDIA recommended vendors list. And this required very specific design practices in order to meet the strict specifications that are required for implementing Blackwell in data centers. We also are launching here in Cannes a new solution called GigaModular, and this is the world's first modular scalable CDU for AI implementation, and it ranges in total heat rejection from 2 megawatts all the way up to 10 megawatts. So supply chain continues to be a challenge globally. And it was exacerbated more recently by the tariff situation, where we're seeing, certain impacts from U.S. tariffs as well as reciprocal tariffs. I think at the moment we're seeing about a 4 to 5x imbalance between demand and supply, which is putting a lot of pressure on the entire industry. We have actually proacted to address the capacity issue and added a second factory in Dallas-Fort Worth. And we're having a ribbon cutting for that facility in just a few weeks on June 18th. But in addition to that, we're also looking to expand our manufacturing globally in Southeast Asia, the Middle East, and India. Well, NVIDIA's already published their 3-year roadmap. And what we know is that chip TDPs are going to continue to increase. And rack densities reaching 600 kilowatts are already on the horizon. We know that TDPs will continue to increase beyond that. And so we see the implementation of two-phase liquid cooling solutions on the horizon as well. And this includes two-phase direct-to-chip as well as two-phase immersion, and then also the hybridization of direct-to-chip and immersion cooling technologies. We're working very closely with industry associations, our clients, and also academia to address some of the future needs that are around the liquid cooling segment.